All right, recording has started. Perfect. Hi, everyone. Thanks so much for coming. So as Matt said, this is something that it's been almost a year in the making. It's an idea that was sparked almost a year ago. We did the little demo at the hackathon, and since then I've still been toying with it and trying to make it more and more usable and trying to understand better as well everything that's happening under the hood. So the presentation today is sort of the culmination of all of that and trying to share this knowledge with all of you, because I think there's something in there that could be really interesting for the future of development in Rails. So let's start first with a quick survey of the room, trying to get an idea of who I'm talking to here. So who of you are using Rails on a regular basis? All right, big number, cool. What about React? Also a huge number, all right. So there's a lot of companies that are using React. I think that shows, that's good. React and Rails work well today. But there's also this new kid on the block, Hotwire, the new one-person framework approach that Rails is pushing forwards. Are any of you using Hotwire also on a regular basis? 1, 2.5, all right. Good, well, if you're one of those people, you might feel something like this, and hopefully my clicker is working. No. All right. I'll try to get it working, but yeah, you might feel something like this. So this is a quick meme I found, and yeah, like React is so 2022, right? In 2023, Rails released Rails 7.
I thought Hotwire came out in 2021.
Oh my God, maybe. Kind of like,
I get that meme though. Totally.
Yeah, it was set as the default on Rails 7, I think, if I remember correctly. And so it gained a lot of adoption, at least in the last year and a bit more. And yeah, clearly, like there's a lot of interest in this, right? Because there's a lot of benefits, right? You don't need to know React. You can develop faster. You don't need a new data fetching layer. But I'll get into that. What I want to talk about, I think my clicker isn't working. So what I want to talk about is that I think there's still a place for React in the development world. Right? Yes, maybe you can go faster with Hotwire, but Hotwire and similar solutions, right? Like HTMX and things like that. They aren't particularly well suited to like what I would call front-end applications, right? Not just a web page, but an application that has a ton of state and UI management, and that has just a complicated set of features that that it needs to support. And for those purposes, I still think that React is king. So some of the pros that I think still makes React a winner in some cases, I think it's sort of a decision you have to take on a per project basis, is, well, first of all, that it might just be already built into your company and your code base. You might have a team that's already proficient at React and is using it daily. You don't want to refactor all your code, refactor your design system to something completely different. That would be way too big of an undertaking. And then what I mentioned is that React is still king of UX. You can do everything through Hotwire, but you might need to put a little more effort when you want to just get the experience just the way you want it. And finally, arguably, it's also an easier development mental model, especially if you have a complicated UI. Then this notion of UI as a function of state, where the whole UI is defined from the state, is something that's very convenient. Yes, Andy?
I agree with the arguably, because ELD is way simpler than React.
Yeah.
And like Hotwire, the idea behind Hotwire is way simpler. The other thing I wanted to say, King of UX is becoming disputed now. I presented last month Deliver DSL for Web, which lets you use Ruby in the front end and write half the code you write in React in Ruby instead. Check it out, guys.
Yep, so interesting. And yeah, like I think, every technology has a specific, like there's going to be pros and cons to everything. And I don't think there's one king for all projects. I think at the end of the day, you need to take the right decision for whatever you're building. And React, I still believe, is one of the good options today. But it comes with some downsides. So if you've been working with Rails, React on Rails, as many of you have been have said that you do, then you might have noticed that, there's slower development. You need this extra data fetching API, often GraphQL, sometimes REST. And on top of that, you also have slower page loads, right? So you need, there's this extra round trip request that needs to go from the client to the server to fetch the data. And so you might get into this sort of spinner hell that you might have noticed on some React pages, where you start loading the page and then there's a bunch of spinners that are waiting for data to fetch. And then once that's fetched, maybe it loads components that also themselves need to go fetch more data. And you get into this, what they call a data fetching waterfall problem. And finally, of course, it's larger JavaScript bundles, which might lead to also a slower page load time. So just to exemplify the waterfall problem, I'm going to use this type of diagram a lot today to go over the pros and cons of different approaches. So the server sends the client the initial web page and JavaScript bundle. Then the JavaScript bundle, once it's loaded, that means React is loaded and it's able to render the page. And then there's that round trip request to go fetch the data and then render that finally. So that's the situation today. And this presentation, what I want to go over with you is like just try to figure out how we could make this better. How could we make this closer to Hotwire HTMX while keeping the developer experience also great and ease of use? Yeah. So when I see this, the first thing I think about is, let's try to remove the round trip. Right? Why not just fetch the data directly at the start and send that straight to the front end on the first request? And we can do that. Oh, I hope you're sitting close enough for the small code. I apologize. And we can do that. And today, this is already supported in most React integrations in Rails. So what I'm showing at the top here is the ERB file, the template, where there's a helper method, in this case called React component, where you can specify the React component you want to render on the front end. So from the back end, you can already specify what you want to render and pass it the props that it needs. So you can already pass it all the data it needs, technically. And just to give you an idea of how this might be implemented under the hood, usually you'd use a gem for this, but under the hood, it might look something like this, where the helper gets replaced by this sort of template div that contains, data attributes that specify what's the React component you want to render, what are its props. And then there's a little JavaScript piece of code that can run and dynamically load the right React class and pass it the props and render that. All right, so just quickly go over this pseudocode, completely untested, by the way. But you get this element, you get the class that you need to load and import that dynamically, and then parse the props and create the component and render that in the route that you've instantiated. Okay, and now, great, we've already solved the problem. There's no more waterfall. But there's a key cost here that's kind of hidden and not shown in this diagram. Talked earlier that we still want to maintain the developer experience and speed of development. Well, there's something here that's going to be very annoying. And so if I show you, for example, what the entry point component might look like, that can give you a better idea of where that problem lies. So here's an example page in the entry point component. It might use a card from your design system, some HTML elements like the header, and then have some sub React components used as well. In this case, I just used a body and footer. And keep in mind, those body and footer components are themselves going to have many children of other React components, and you're going to quickly get into a very huge tree of components that need to be rendered. But the problem here comes from the fact that the props that you're passing from the server, well, they need to be distributed around to all of the specific React components on the front end that need specific data points for them to render the correct thing. And so you run into this situation where from the back end, you need to know not just all the data you need to render, but also format it in a way that the front end can distribute it to all the right components. And then on the front end, you get stuck with this problem of distributing all of that. So you end up with a prop drilling problem, commonly called, where you keep having to redistribute the props and then pass them down to their children who themselves have to also pass it down to their children. Yeah?
I'm curious, are you a fan of using React contexts to solve this problem? Or part of the problem at least?
Personally, I don't know if I'm a fan. It depends on the situation. Here, I don't think it would solve the problem, right? Like, you'd still need to come up with a common structure of the data that the front end and the back end would agree on to as to where you go and get
Sorry,
that.
I meant the problem of passing the props over
Yeah.
to like 20 components.
Yeah.
It's just like having them pull it from the context.
Yeah, it would definitely solve the problem of like having to explicitly pass it, but then you still need to know where to go look for that data. So the components aren't as reusable anymore because they need to know exactly at what key they need to go. Yeah. But yeah, I mean, at least you can clean up the code a little bit, let's say. Yeah. Yeah, so this is what this might look like. And so is there a way that we could make this better? Is there a way, we want each component to be able to know, to have all of its data that it needs, but the backend that would like to maybe directly pass the props to to the front end components that need them? And so we can come up with a sort of pseudocode that could look something like this. Maybe we could, in our view, instead of rendering one entry point component, start thinking about rendering a whole tree of React components. And so here I'm reproducing the entry point, but in the view, and the React component helper, now I'm kind of imagining that it can support a block argument where you can pass children. That is not the case of any React on Rails gems that I know of today, but theoretically that's possible. And you could, this way, specify a whole structure of the page you want to render, like the whole React tree that you want to render. And now your props, well, you can specify directly the props that each component needs, right? And you could even, think about making a backend notion of a component as a model that knows exactly the React component it's rendering, the props it needs, and it could take care of data fetching for that. You could come up with a whole framework around that. And so just to show you that this could work, we could do, let me show you what what this template might render down to. So we have the similar template, like divs used as template at the top here. So we have the React card with the same children. And here, notice we're using other templates within that for specifying the body and the footer components. And then the only difference in the code is that now we can iterate over the children of the component we're looking at. And for any of those, import the right React component, pass this props, and basically we're rebuilding the JSX tree in this little bit of JavaScript. So again, skip some corners here, not handling correctly the DOM node for H1, but you can imagine how this could work. All right, and so we have this great situation now where there's no more extra round trip. The database queries are all done at the start. All the data is sent to the client, and you try it in production, and you get users that are a bit like this. I'm going to take this moment to take a sip of water. So what happened? Well, we didn't really think about this scenario, right? Like what happens if your props, like all the database queries that need to happen to fetch all the data, take a while. And even if they don't take a while, now your client, your users still have to wait for the entire time that all the data needs to be fetched before they see something on the page. So the first contentful paint is happening much later than before, right? And just to show you, let's compare that to what the situation was with the traditional React on Rails approach. Right? So the first contentful paint happened as soon as we had React starting to render on the front end. We didn't need all the database queries because that happened in a separate API call. So at least the user had some initial feedback and knew that something was going on. They didn't have to, wonder if the page was even working at all. So let's think about how to solve that problem. But first, I want to take a step back and revisit the format that we've been using to pass down this JSX template that we want to render on the front end. So right now, like the latest version we had was something like this, where we were using HTML to nest a bunch of placeholders to be used to identify which of those are React components and how they should be rendered. But we could just as well use JSON for this, and it's going to make our data parsing or the parsing of this structure much easier in the future. So let's switch over to JSON just for the sake of this demo. So we can have the same component representation, the same JSX tree, as a JSON where you have a root component, the card. It has some children. And each children can have, is also a component in itself and has some props optionally. So we have the same data definition. We can do the same thing and send that, through our ERB template, for example. We could just send that as JSON that we store in a little JavaScript variable. We process this thing the same way as before, or the same way without the DOM manipulation or the DOM lookups. But basically, it could be just a different approach to passing the data from the backend. All right, so let's circle back to the slowness problem of the data fetching. Let's say that in our example, it's the body component, the props, for the body component that are very slow to load. What we could do is instead just maybe not show the body component, right? Maybe we wait. We wait until we have the right data. So we could put a placeholder instead and just say, look, front end, wait for it. I will get you whatever needs to go there. But for now, just keep in mind there will be something that goes there. And then the second key idea is that we could change this format into something that's streamed from the server. So our server would initially send this, but then as soon as the data is ready, as soon as the placeholder is ready to be replaced, then we keep adding some more lines to the stream that contain whatever needs to go and replace that placeholder. So it might look something like this. So first, we get the first block, and then a few seconds later, we send out another block containing what needs to be rendered with the ID that references where that needs to go. And so now the only question is, how do we actually render that on the front end? And that's a tricky one. So let me actually go back. The first part we've done, right? That works. And the placeholder we can just skip or put a empty div if we want to. But how do we, after React has rendered something, how do we go and hook into the render process to add something that was initially missing? That's actually very tricky to do in React, right? Like having this interaction with React from outside React world is pretty tricky. It's possible, but not super convenient to do. But fortunately, with React's next release of server components, they have an API to do just that. And it's called create from readable stream. With create from readable stream, you can pass a data stream directly to that function. It expects a specific format, which we'll get into. But it can then render that content directly in the JSX and even do some nice things for us. Like it will actually be integrated with the React renderer. And we'll see in a few slides like some of the benefits of that. But the only thing we need to get this working is basically to use, so to pass a data stream in the right format. So React expects a specific format, as you can expect, to know how it needs to render the React components using this method. And so we had our JSON format. This is the actual React format. Well, actually, it's one of the previous versions of what this wire format looked like. Since I built those slides, the format has changed slightly, but is still very similar. And so this is very close to our JSON approach. You'll notice that our block here of line 0 is the main content that we're trying to send. So with a few differences, right? So first of all, the first two lines are indicating where to load certain React components. In what files are they? In what chunks are they if you're using Webpack and it's chunking your JavaScript? And at what import name are they? This is something that I kind of skipped over in the previous implementations, but it would have also been required to be able to implement any of the previous little scripts that I showed. And so this 0 block being our main body or main page that we're trying to render is first referencing line 1. And so it's saying, OK, this is first of all, a card component that has props. Here, the props would actually be expanded. You can imagine that you might be passing some data here. And then it has children. And in the children, same as before, we have our h1 header with its title. We have our placeholder, same as before. We just put an ID reference. And finally, we have our footer, which itself is also a front-end component. So it needs to refer to the line where we defined that. And it has its own props. And then this is highly streamable, right? The idea behind using this and not JSON is basically just that it's a little more compact, so you're going to send a little less data over the wire. And you can stream this the same way as we talked before, where after a few seconds, you keep the connection open from the server, and once your data is ready, stream the final part. So in this case, the last body component and its props. And this will work directly with this create from readable stream React API. And now, well, now our picture is looking much better. So now that means you can have your front end, which right from the start is getting this initial payload with the placeholders. So it renders really quickly, and you get a first contentful pane that gets quickly into the eyes of the users. While in the background, your server has already started doing all the data fetching from the database. All those slow queries are already running. And only once they're ready, they get streamed to the front end. And you get to render, and they render as soon as that's ready. Oh, yeah, sorry.
So you have two render parts, render shell and render content. Is the shell that like a skeleton layout?
Yeah, in this case, the naming is a bit confusing. But imagine the shell being like the JSX tree we sent with the placeholders. And then content is once we have everything final. Right? In practice, though, with this structure, you can actually send data in pieces, right? You can have many placeholders, and each of them can be streamed as soon as they're ready. So you might have like multiple different arrows that come in from the data from the backend. As soon as that's ready, you keep rendering a bit more.
When you're rendering the shell, is there reflow that's produced once the content loads in, or?
Yeah, exactly. Yeah. So that's one of the challenges we'll tackle in a minute. But yes, definitely like that placeholder that we put right now is nothing. So once you add the thing in, it's going to make everything jump in the page, and that might lead to a bad user experience. I think that's actually my next slide. Yeah. So what do we show while the elements load, right? Because again, we would have that jumping problem. Well, React has an aptly named suspense API just for this. You can wrap your elements in suspense, provide a fallback. The fallback is what's going to be rendered until every children of this has done loading. And now you can specify, for example, a skeleton so that your page doesn't jump, right? Or just a big loading spinner. Yeah?
That's React version 18, right?
Yes, correct. But the nice thing about using create from readable stream is that since it integrates directly in the React renderer, well, it supports suspense as well. So all those placeholders are directly supported and will be able to make use of suspense and show the fallback until the placeholder has been replaced by the actual content you want. And yeah, so just to show you an example of how suspense might be used in JSX, so in our entry point component, you would put it just to wrap whatever you want to show a fallback instead. So in our case, maybe just the body, but note that we could also hide the entire page if we wanted to until the body is loaded. And in our case, we can show like a spinner from our design system component, let's say, and that will be the placeholder until the data is loaded. And all we need to do now is specify the suspense as part of our tree. So we just need to adjust so that this change is reflected as well in the data we send from the backend. And so our wire format is changed slightly. Our children of the main block now have the L3 reference to suspense here. Suspense being just a sort of constant string. I don't know exactly why they picked that in the format. And it specifies the fallback as a prop right here, which is itself a reference to another front-end component called spinner. And itself, and the children is where we put the placeholder for what we want to load later. And so basically, the whole conclusion of this is that to make React Server components work in Rails, all we need to do is replicate their wire format, replicate that streaming format that I just showed. So we need a way to go from a definition of the components on the back end, render that down to this format, support streaming so that we can add lines as soon as the data is all loaded. And Bob's your uncle. You plug that in to create from a readable stream on the front end, and you got a working version of this. Yeah. Yes, Andy.
I have a question. So this format that you just showed us for the streamable data.
Yeah.
So that comes from the React Server Component standard.
Exactly, yeah. Unfortunately, they have very, very little documentation about this format, which is a bit sad because it kind of feels like they're locking this into just a Node.js backend world. But there is starting to be more and more documentation, more people digging in. Of course, the source code is also open source. So it is possible to replicate this, and I'm hoping to see more efforts from the community as well in the future for that. So I went ahead and tried it out. That's like what we started at the hackathon last year. Over the last year, I've been refining the code a little bit just to show you something working in this. So I'll jump over to the demo and yeah, just show you an idea of like what this might look like from a user perspective, but also from a software developer perspective. On peut faire ça. C'est bon. All right, 1 second.
Via your life.
All right, I think we're good to go. All right, so this is the React Node demo. Actually, this is a demo that the React team themselves built for showcasing server components. And what I did is I took the demo and re-implemented all the backend in Rails. But the front end is basically the same. So if I refresh the page, you'll see, well, okay, that was a bit too quick. I think a lot of stuff was cached, but it's also running on my local host. So there's not too much to see. But just to show you some functionalities of the app, it's a note-taking app. You can click on the notes to see what's happening, the contents. You can edit and change what you want. You get a preview on the right that updates in real time. And when you're done, you can save everything. You can also search. And you can create new notes, but I'll skip that for now. So this is basically the simple app. And just to show you so this is all running with a Rails backend, but just to show you the streaming aspect of this, I'm going to slow down artificially what happens when we load a single note. I'm going to go back in the code and just put a sleep of 2 seconds in here. And let me refresh the page just in case. And now if I click this note, you'll see the skeleton I was talking about. So we're using the suspense to show a fallback, and yeah, and I can show you in the inspect tab, the network, what's happening here. And so you'll see, just move this so it's a bit more convenient. Wow, this is not working well at all on my laptop. Okay, sorry about that. You're not going to see much of the the stuff on the left. Ah, that's why. I probably was on a bigger screen right before. Okay, there we go. So there's the initial page load. In this demo, I'm cheating a little bit. The streaming format isn't sent with the first page load. It's actually a separate API call that the front end makes to get the data. So we are back to the round trip problem. I swear this is just temporary, and this is actually to match the server components demo that React did. They also do the same thing. It makes this much easier. If you want to stream the data directly with the first page load, you have to embed that into the HTML. And so you might have to use an open-ended HTML that at the HTML page that at the end you keep adding like script tags that keep pushing data into an array or something like that. A little more complicated. This makes it just a bit easier, but it is possible to also send it with the first page load. And so this first page uses the wire format. So you can see here the response. I hope this is visible. Sorry for the small screen. Yeah. How about that? Yeah, perfect. So our API that returns the streaming format, you can see it's working. And if I click on a note here, I do not see it. There we go. So it streamed the data. What I'll do is I'll go over and copy this to curl just so you can see the streaming happening. And so if I launch the same query, you'll see we kind of stopped here around this line. This was the main block starting with 0. And then the final content loaded. So after this stuff here, it took a couple seconds, and then we finally got the rest. The rest being, in this case, the content that would replace the skeleton on the right. And yeah, to show you a little bit more about how this looks like from a developer perspective, let me show you a bit of the code. So to render this wire format, we first need to define the tree of React components and HTML elements that we want to render. So I decided to go with an approach for this based on Flex. It's not ERB like we've been doing since the start of this presentation, just because I would have needed to parse HTML to then render it to this wire format. Not as straightforward. Using Flex is a bit easier. It's all Ruby, and I can hook into the methods to render it exactly how I want to. So just to show you the main app. So with Flex, you have a template method in which you define like all the HTML elements you want to render. And in this case, the only key difference is that you can render as well the front-end components. So here you'll notice the search field and the edit button are actually front-end components. Yes, Andy?
I just wanted to mention, Flex is about 2 years old, but its component structure and API is almost exactly lifted from Glimmer originally. Glimmer it was created in 2007, the desktop version of Glimmer. And Glimmer copied something else. It copied shoes and Mercari. So Flex kind of copied almost exactly the same DSL of Glimmer. So what you're showing us here is very similar to Glimmer's DSL.
Awesome. Great to know. So yeah, I could make even an implementation of this with the Glimmer DSL that renders down to this wire format. And so the developer experience is pretty much the same as a regular ERB template. But on top of that, you now get an easier way to specify front-end components. And the second new thing is this suspense notion, right? So you can wrap some certain parts of your code in suspense, specify a fallback, and then you can render some components that might take a while to do data loading. In this case, the note list component I can show you, which we specify as an async render type of component. This is just the little flag that we use to identify that. And with this async render, what that's going to do is once we run the render method for this component, we're going to spin that off into a new fiber, render the code asynchronously, and only when it's ready, stream back the data to through the stream that's been open. But yeah, any questions about the code before I go back to the final points of the presentation? Is there anything specific you'd like to see or something you think I forgot to demo? Also possible. Yeah.
I'm confused though. When should we use React components pure of rendering purpose, and when should we use, for example, sections and include like style stuff? Because looking at first, for me, I'm confused of where we are separating the layers of what should be like in the Ruby, what should be only React.
Yeah, that's a really good question. Actually, this might be a new problem and a new question that like needs some standards and conventions in our code bases, but it's a good problem to have because now you can decide how much of the rendering do you want to happen on the back end versus on the front end. And you can do this on a per component level, right? I can turn this section into a front end component and nothing's changed in my code, right? Like you want to add interactivity somewhere, okay, just move that component to the front end and you're good to go. Of course, the React implementation is a little nicer there in the sense that you don't need to rewrite your Ruby code into JavaScript. It's still the JavaScript with React. And if you move it to the front end, you get access to state and hooks, right? But transferring from this format to the front end is also not that bad. And you can still do a split of like having a backend that takes care of all the data fetching, like a component for data fetching, and then a component for rendering and user interactivity, and that would still work within this framework. Like you're on this definition here, right? You can have your section that fetches the data and passes it down to the front end component to render it.
There is a super flexibility inside.
All right, so let me jump back to the presentation real quick. I'm gonna just share my screen once more. I think it's gonna be easier. Okay. All right. So what is this React Server Components feature then, right? So we've seen today that it's pretty much just this specification of the streaming format that we saw. And on top of that, it's an API on the front end to take that definition, to take that stream and render that to the JSX tree. It's also on the back end an API to render so backend React components or components that don't use state and certain other hooks down to this wire format, down to the streaming format. So in this sense, it's technically support for rendering JavaScript React components, either on the server or on the client or both, right? There's a few catches, like so the use state, stuff like that. And on the server, you can use async components and do data fetching directly from your database. So there's maybe even an argument that like having them in separate languages is a bit clearer. You don't risk trying to do database fetching from the front end, which wouldn't work anyway. But you don't risk injecting a secret key in a front end component, for example. Yeah, Andy.
I disagree with that. I think developers would be a lot more productive if it was one language on the server and the client. Because I used to program apps that were client server before the internet started, and that was a lot more productive than the waste of time that we have nowadays with 4 or 5 different languages. But what you're showing is very interesting. Sorry, I'm not interrupt you.
Yeah, no, it's super interesting. I think actually, most of the logic you're going to have is going to be around data fetching or around like front end state and interactivity. So these are already things that have to be either on the front end or the back end, right? You can't do the data fetching on the front end. You can't do the user interactivity on the back end as much. And so given that, the stuff that actually needs to transfer between front end and back end component for me is just this simple definition of like hierarchy of components. And that is easy to transfer. There's a bit more logic, obviously, but I think it might be a worthwhile trade-off. And then my final point here is that it's also pretty bare bones, right? It leaves a lot of choice for framework creators. And we had to dig pretty deep into the internals to figure out all that stuff, right? And that's because actually React has decided to position themselves now as what they call a meta framework. On their official documentation for the next release, they don't recommend you use React directly. They don't recommend you use the lib directly. They recommend you use a framework that is set up to use React and set up all the stuff around server components for you. Because there's a lot of stuff to worry about. And this demo, it was the simple part of that. But then there's a bunch more about race conditions of what happens if your stream doesn't load in the right order. And then we'll get into SSR in a second, of server-side rendering. There's a lot of complexities around that. And React is arguing that you're better off just leaving that to a full-fledged framework that has already handled all these edge cases for you. But the one thing it is not, though, so server components are not server-side rendering. And React makes this very clear distinction between the two. For me, at first, I was like, what? What do you mean? They both have like server in the name. For me, server components are rendered on the server. Like you're rendering down this tree to the streaming format. But the distinction that React makes is that the rendering to the streaming format is different than rendering to HTML. And that's what they call server-side rendering. So they also have an API to render all the JSX components, including the front-end ones, directly to HTML from the server. So that way you're able to send a first payload to your users that already contains the built HTML. So they don't even have to wait for the initial React rendering on the front end. They don't even have to wait for the JavaScript bundle to load. And in fact, you can combine these two into something like this, where now your server can do the server-side rendering. That's my first step here. So send the HTML down to the client directly. The client already has something visible at that point, and then can start downloading the JavaScript and do a process they call hydrating, which is just attaching your JavaScript code to the already existing HTML as opposed to rendering it from scratch. And in parallel, you still have the same process of fetching all your data and streaming that to the front end through React Server components. And now you get the best of everything, where your first contentful paint happens really early. The page becomes interactive as soon as the JavaScript is loaded, and then your final content paints, it streams in and keeps painting as soon as it's ready. And so just to circle back to one of the first slides I had on React in Rails today, well, what would it look like tomorrow now if we take into consideration everything I've just presented? So the pros stay the same, but the cons now, well, the slow development, well, now you don't need this data fetching anymore, right? This GraphQL API was only used for the front end to have a way to go and query what it needs. But now we're passing all that down directly from the back end, so we get rid of that. And then the slower page load, as we saw with the combination of SSR and React Server components, well, you don't need the round trip at all. In fact, you can even render stuff from the back end directly down to HTML, and it's going to be even faster than before. And the final point, the larger JavaScript bundles, that still holds if you want to use React in the front end, because you need interactivity, you need all the nice methods behind this. It is a little smaller, though, because now you can pick and choose what you render on the front end and on the back end. So you might decide to offload some of the stuff to the back end, which might also mean you don't need to use this specific NPM library anymore, and you can just use a Ruby gem equivalent or something that's already built into Rails. Yes?
I don't remember which library did this, but there was one that I had heard about being 6 months to a year ago, which essentially didn't download any of the event handler code. Like you,
Oh, I think I know.
On it,
are you talking about Quick?
Down the code.
Is it possible you're talking about Quick?
To tackle the larger model sizes.
Yeah. So this is that's a good point. So what I've talked today, right, is about React specifically, because React is the first of the big front-end libraries to start implementing this kind of stuff. But if this picks up and people like it, then I expect a lot more front-end libraries to support this kind of thing. I think that the library you're talking about is Quick. I don't know it super well, so I don't know if it's really compatible with this sort of development model. Definitely other libraries, and they're also building frameworks like Solid.js, a Solid Start, for example, right? They might start looking at something like this. And I used React today, but really you could substitute that for anything else if in the future they also add support for it. Yeah.
I had a question. So you mentioned that we're minimizing or eliminating data fetching API calls. That's because now you're relying on streaming for rendering the parts that are not rendered right away.
Correct.
Whereas in the past, they ended up fetching extra data later. Got it.
Yeah, correct. And I believe that was my last slide. Thank you, everyone. Just as I guess final words, I put a slide in there. I'll share the slides with everyone in the meetup. I put the slide with references if you're curious about where I learned about this kind of stuff. And I also put a link to the demo code. It's all open source for the version I built in Rails. If you're interested at contributing, go ahead and reach out. I'm not sure how much time I'll have to actually turn this into a framework. It's something I'd love to do, but we'll see what happens. But if you're also interested, reach out and we can talk. Yeah, Andy.
So the problem that you presented, we have it solved in our code base at my company, Next.js, by basically, we usually pass any data that is available right away when we render a page immediately to the React components. and then we defer any data that needs to be fetched later into the components themselves. And we don't have a problem where, like, basically the page will render right away, and the components that need extra data will make extra API calls. And we haven't had any issues with that, to be honest. I mean, Vic, what do you think? Do we have any problems with that? I don't believe so. We have it solved just by simply making the components responsible for whether they want the data to be received right away in the params or arguments, or whether to make the calls inside the component and not render anything. As soon as the data comes in, it pops up. So I'm curious, is that a solution? Like, is that a problem for you guys? Was that a problem? Is that part of the reason why this was created?
Initially, the app was built as a single page application with a single page application and relying on the design system heavily. So everything was built with basically a placeholder, a div root, and you're done. So there wasn't any mixture of some ERB code and some boilerplate that you could do in Rails, and then plug and play React. We needed that interface to be, I don't know, I guess an example would be if you're building Gmail, right? Pretty much there's no like individual components that you would then later attach together. It's the full thing. And Gmail will have a single spinner on the entire interface. Our app is built the same way. 5-6 years ago, it was the trend, but also it fit the use case that we had. So yeah, there's a way that you can build the app and you can have dynamic components this way, and you won't be facing this. But if you need the UI interaction to have this extra oomph, and you are in a single page application paradigm, then yeah, you kind of screwed because you don't have that possibility. The other thing is really the design system that we had. We're not CSS based, we're like CSS and JS and material UI and other things like this. So are we still CSS and JS? I'm not even sure. Yeah, we are. Okay, we still are. So basically anything that you're building needs to be JavaScript based because otherwise there's no design element, there's no color, there's no nothing. And so that's the single page application. That's
CSS. CSS can be applied to
CSS and JS is something else.
Oh, got it.
Yeah. It's where you're basically defining the CSS as you know the JavaScript components. So it's two different paradigms. You join both of them together, and yeah, you're not in a world where you can develop a front page, a front end application that can reside with a mixed scenario of some back end rendered stuff and some front end rendered stuff.
So you're saying your Rails app has like one view which renders everything there?
Just run equally.
But why didn't you make it like an API in a different format?
What do you mean by API?
Like build your Rails app as an API and then
Yeah, that's pretty much what it is.
Yeah, it just has like features which has some process.
Feature flags and other things are still intertwined.
You can have it like complete separately, but
so that you have one huge DLB file and everything is
for each entry point, yeah.
okay. That's a different way. I mean, we do it differently.
Obviously, many different ways of doing this. The paradigm that we had in the day, we still have today, is a user experience that requires this sort of rendering. And also that's how we build the design system, meaning that the front-end developers had everything available to them in JavaScript. Without getting into coding, but from a hiring perspective, it's quite hard to hire Ruby devs of a certain seniority that know full stack entirely. So being able to hire JavaScript, TypeScript developers to concentrate on the front end was also kind of the idea. So you have like a mixture of many decisions that.
Yeah, but they end up costing you 200% the cost you would have built it with Ruby. It would have cost you if you used Ruby. That's my experience, or even 400%. JavaScript is awful. JavaScript is a disease. Yeah, I mean, I really liked your backend part that was similar to the Glimmer DSL. It's a shame you didn't attend my talk last month.
Sorry, I couldn't make it.
It's online on YouTube. It's called Front End Ruby with Glimmer DSL for Web, because it has you have the backend piece, of the puzzle solved. Glimmer has the front end piece solved. It would be great to integrate the two together. So I definitely want to discuss that with you after the talk. The front end part in my opinion, nothing intriguing or interesting comes out of React. And I didn't think server components were interesting at all. In my opinion, it was extreme over-engineering from what I saw. And a lot of the front-end code that you showed us is extremely ugly compared to what I showed last month. So, I mean, to me, that's like you showed me PHP in 2005. I showed you Ruby on Rails 2005. Sorry, like that's what I meant.
Yeah. But what's
also it's kind of like somebody showing me the first car, but I showed them the first rocket. The car is nothing, like compared to it. So definitely check out my talk, front-end Ruby with Glimmer.js.
I will.
This is thinking inside the box of React or what's common in JS. What was demonstrated last month was completely outside the box. Like a much simpler solution that ends up shrinking the code by about half. So, anyways, that's all.
Sounds super cool. I'll try to check it out. Just the front end. Actually, I didn't really show any front end today, right? What I showed was like what would be hidden behind a framework or a library. The front end stays the same old React. So if you don't like that, you're not going to like that today. But it doesn't change your front end. It means that your existing design system can still work, and you don't have to change anything about that. And you asked earlier about like what problem this solves. I think it's depending on your use case, you might actually be running into bottlenecks of performance or scaling problems that make this kind of solution interesting. I think overall, though, the main purpose of React Server Components is more around developer experience. It is about building this kind of optimized architecture, optimized delivery system for the users as easy as possible, and in a way where developers can now very easily choose what goes on the back end or the front end. And one of my favorite arguments for this is like the ability to co-locate everything that's related to one sort of thing or like entity that you're rendering on the front end, right? Now you can co-locate the data fetching, the JavaScript, the data fetching and the component and all the rendering all in one place on your backend. And I find that mental model of development very, very convenient. I'm still not sure if this is the way to go for the future. I think this is very, very new, and the community also seems to be divided. There's also a server actions, another feature from React that I'm much more on the edge there, like as to whether that's actually interesting or not, or if that's dangerous. So I think next year is going to be interesting, and I want to build this because I want to jump in and see what could come out of it, and if this is interesting.
So that backend DSL that was in Ruby generates JavaScript code, is what you're saying, or React components on the front end?
It just renders to the streaming format. That's all it does. Yeah. Any other questions? Yeah.
Probably from a testing perspective, now that you are, how can I say, leveraging over streaming responses, how did you deal with testing, for example? Because let's say tomorrow you want to make sure that you are rendering 50 records from the database, and since now you are using a lot of streaming, what happens if for one test it will probably get 10, or for the next one it will gonna get 20? Like, have you experienced flakiness in the past because of that?
That's a really good question. The reality is there are no tests for that demo app. This was just built to see if it works. I think I have a couple backend tests just to make sure I can render to the streaming format, but that's about it. So this is untested grounds. I don't know. I think you could, fake the streaming, which sounds very ugly and inconvenient, but if maybe you have some helpers for that, could work. Like you can test your front end by faking the back end, then at least you're starting to get somewhere. Otherwise, have a way to disable the async component, maybe. I'm not sure. Yeah, it's interesting.
Saying from a personal perspective, I don't see, like, depends on the case, sure, but much like value of testing only the return of the data, because in the end we can either do like a system test to check out user behavior, or if you would like to check the return of the data, it doesn't need to be from the stream itself, can be for a unit test from a part of what you would like to return itself. So you either checking the data from a service, or you can also check the behavior from a system test. Like a test from the response itself being the data. Yeah, I don't know.
I don't know. Yeah. I mean, the streaming format is parsable. You could have utilities helpers in your RSpec test to, in a request test, for example, to check that it contains the data you want. Yeah, I think that's probably the way I'd go.
Is the streaming breaks essentially JavaScript unit testing? Or would you still be able to load up a component and fake the data, the props that would be coming in? You need to go through streaming because you mentioned you could fake the stream data, but geez, that's unreadable. So,
yeah.
Does it break it, or there's still a way to?
It depends, right? I guess like if I was to do unit testing on the front end that rendered individual components, and the streaming would happen outside of that, right? Like the create from readable stream method, which would be what's problematic, would be happening in some sort of entry point file, right? In like the sort of root JavaScript that's injected by the framework. And so you don't, for unit testing, you just load the component that you need. It doesn't care about any streaming. You still pass the props just as before, right? It doesn't change any of that. It's really only if you want to do like more of an end-to-end test, more of a system test, I think. And in that case, you also have the backend to complete. So
same thing.
Yeah. All right. I guess I'll stop the recording here, but feel free to ask me more questions after. Come talk to me. I'll stay for a bit before leaving. And thanks very much for coming.